there are so many differences for different applications. And from my understanding, because for aqua feed, they are using a lot of ingredients. Soybean, feather, and fish meal, and husker, a lot of different material. So many different material because their thermal coefficient is quite different. So they need really long time to have steam to forming penetrate into different ingredients, because different ingredients their thermal coefficient is quite different, and the need time to get the uniform, right? I can show you here. Here you can see they have different thermal conductivity. This is for corn, and this is for sorghum, and for different ingredients. You can see their thermal conductivity is different. So this is just a glance, and I just want to say, for aqua feed, so many different ingredients. Their thermal conductivity is quite different, and it needs longer time to achieve the uniformity. Uniformity, steam penetration, water penetration. But for pet food, because for pet food we know that we don't have as many ingredients as aqua feed, and for human food, even just a single ingredient. So we don't need time to get a uniform penetration of steam, right? So that means for pet food, we can use the 2-stage. That's enough. We use the conditioner to inject the steam and moisture, or oil or slurry, and for recreational, we really need some time to soften the material to reduce the torque of the conditioner, right? But I want to highlight that when we choose conditioning for different application, we need to be very careful, because if we want to have a high mid-slurry addition, then we need to make sure that our conditioning system can achieve the good mixing homogeneity. Maybe you know that for winger they have a type of conditioner, DDC, which is HIP, high intensity preconditioner, right? That DDC is quite different from other application usage, because their speed is quite high. It's almost a double time higher than the DDC used in aqua feed, because they want to have a very good mixing homogeneity. So they increase the speed for the DDC. And also in Bueller, we also have two types of DDC. One is a low speed, and the other is high speed. High speed is especially designed for the high mid-slurry addition, because for high mid-story addition, let's say sometimes we add around more than 50% of a mid-story into a conditioner. At that time, the retention time, the steam thermal energy is not useful. We can't input so many steam or water into the conditioner anymore. So the retention time is not as a critical point for high mid-story addition. But high mid-story addition means we need to have a very good mixing homogeneity. Otherwise, the pellets they are stick together. The powder in the conditioner they are stick together, right? So we need the high speed to break up the nuts, right? So it depends on what application you are going to use, right? And also for the this is don't need to mention. This is for choice standard for condition. I just want to mention some points that pop up into my mind. And conditioner, then it goes to specific mechanical energy, because we for specific mechanical energy we use the electricity power transferred into mechanical energy, and finally the mechanical energy will transfer into thermal energy. Because the frictional force is too high, then the thermal energy will be higher, right? The temperature will be higher. So even we are always talking about this SME and STE. SME means specific mechanical energy, STE means specific thermal energy, but they final maintain to temperature rise, right? And this is a specific mechanical energy, and most of the time is determined by the screw configuration, right? With strong screw configuration, then we can have a high specific mechanical energy, right? And here, this is a specific mechanical energy. We need to care about this. This is SME, and it's equal to the driving power divided by the capacity. And most of the time, if we want to reduce the energy consumption, we need to control this value, right? Because electrical energy is expensive than thermal energy. So for most of the plants, if they want to control the energy consumption, they need to have this value as low as possible. Otherwise, their processing energy cost will be higher. But the prerequisite for that is we can achieve the qualified product, right? So this is a specific mechanical energy, we need to care about it. And also, in your plant, when you want to choose how many kilowatts we need to have when we have the new extruder, and this will help you to decide how many kilowatts we can have. And for my experience, I just have an easy way. If we have a 3 tons per hour, right? And I can have a pilot trial, and we know for this recipe we need 35, because we have some mid-story addition. Let's say we have 20% mid-story addition, and for this recipe we need 35 kilowatts hour. This is per ton for 1 ton, right? And we want to have 3 ton, and we just use the easy way. 35 multiplies 3 and equals 105. This is a motor power, but we need to leave a space to avoid some sudden amperage higher, right? And usually we need 15%, and we divide by 0. And then we can know it's more or less. This is the motor power we need to configure for our new extruder. If we want to have 3 tons per hour and the SME of 35 kilowatts hour per ton. And this is the SME and also STE. STE means thermal energy. We just mentioned that there are 2 ways for thermal energy, and one is from conditioner and one is from specific mechanical energy that we are obtaining into thermal energy. But except this, we can also input some thermal energy into the extruder barrel or jacket, and that's why we need to have some steam into or cooling water to reduce or increase the thermal energy. Here, this is in a preconditioning, and this is STE, which is a main source of thermal energy. And this is into the extruder. It's mining SME, but its final style, it's thermal energy. It will cause the temperature rise, right? You can see from 30 degree to have another 55 degree increase, right? And here you can see if we want to control the bulk density, and we need to control the SME and STE. That is, we talk about the driving force, because for driving force we measure 2 points. One is pressure, and the other is temperature, right? And for the temperature, we need to control the SME and STE, right? This is easy to understand. And the SME, we can use weak screw configuration to reduce the intensity of the screw configuration, and also we can reduce the temperature inside the barrel. So that's why you can see for bureau extruder they have the density control. They vent the extra steam inside the extruder to reduce the pressure and the temperature inside the barrel. And for the SME, I want to highlight one point because for some recipe, maybe we need very high, quite high as SME. We need a very strong shearing force. But that is not good for nutrition, because with too high SME, that means the shearing force is too high, and that is not a starch generalization. Because starch with too strong shearing force, that is how to say dextrinization. That is not good for digestibility, because animal they can't easily digest the starch. Has detrinized them. So we also need to care about the SME should not be too high, otherwise the nutrition is not good. that's back to the principle again, and we just mentioned the pressure and the temperature, and this is the two critical points inside the extrusion. As long as we can control these two facts, and then we can easily control the bulk density, control expansion. Okay. Do you have any questions for this part? And also viscosity. I think viscosity, for most of the ingredients applied in feed, pet food, and human food, for almost every ingredients in these applications, they are showing force. You see, this is low SME. Low SME means low showing force, right? So you can see it's viscosity is high, and when we input very high SME, you can see its viscosity is lower. There is a showing force. We call it showing thin. With too high showing force and the viscosity is lower, this is a showing thin. For almost every ingredient in the food application, they are showing thinning. So that means with the high showing force, except the thermal energy we can input, and also we can reduce viscosity. With lower viscosity, that means the resisting force is lower, right? And then that explains why strong screw configuration can achieve a lower bulk density, because viscosity is lower, resisting force is lower, because resisting force is from the viscosity of the material. If the material is too thick, viscosity is too high, then the pressure, then the steam, they can't go through this film because it's too thick, right? So it's not easy to get expanded. This is very easy to understand. So reduce the resistive force, and we can increase the intensity of screw configuration. We can reduce the viscosity. That is the principle behind it. This is very important, and I have a table at the end, I think. Thank you. You can see this is for density control and how to utilize all the points mentioned before. And with a higher screw RPM means what? Means your SME is high and viscosity is lower, resistive force is lower, and then with a lower resistive force, and pan is easy to get expanded, right? And also, let's say with water level, with high water level, and that is a special point for water, because for water it's a factor on the expression. It's like this. It's like this. When the water is lower, you can see the bulk density with higher moisture addition, the extruder, the penis, the bulk density is lower. But after a point, when you increase too high moisture, the bulk density even get higher. Because you know, for starch gelatization, they need water. With lower water, the starch can't get gelatized, right? And if the starch can't get gelatinized, and the penis can't get expanded, right? But after a point, when you have too much water added, that means we know the water is somehow like a lubricant. With too high water addition means that you can't input this high specific mechanical energy because water is too high, somehow like oil. Oil is a lubricant, right? And with too high moisture addition, and you can't input, you are not able to input specific mechanical energy. So with a lower specific mechanical energy, then your driving force is lower and resisting force is higher. So it's not easy to get expanded. So the bulk density will go higher. And also all the points and most of the points I have mentioned here for the opening area dilate and with higher opening area, it means the pressure is lower, right? And the bulk density will be higher, right? Easy to understand. So this is why I say to understand this, then you can know, you can adjust most of the parameter for extruder. Then I will here is and ingredients also need mention. You can see this gelatization and dextrinization. This is what I mentioned before. If the specific mechanical energy is too high, showing force is too high, then it will cause not cause gelatization, but cause dextrinization. That is not good for digestibility because it will broke up into small pieces, very small pieces, and they will combine with the other ingredients together with protein, and then it's not easy to the aminos inside the body can't play the effect on the polymers. Protein. Yeah, I think proteins. There are two different proteins: plant-based protein and animal-based protein. For cat food application, I think maybe it's not a trend, but for other application, more and more recipe, they are using more and more plant-based proteins because animal protein, the price is getting higher and higher. But for cat food, especially for the cat food, because cat they just eat the meat, they don't eat the vegetables, right? So you have to give them the animal-based protein. I just want to say for plant-based protein, and if the plant-based protein is too high, that means in your processing you need to add more water because plant-based protein they can absorb more water, much more water than animal protein. You can see here, this is for plant-based protein. Almost every protein in the recipe are from plant-based. And you can see with the same water addition, the surface is not as smooth because it needs more water. So I just want to highlight when you have especially cold gluten. I think for pet food we are using a lot of cold gluten and wet gluten, right? And especially when you are using this type of ingredients, you need to be careful. Maybe we need to add more water compared to other recipes. And lipid, I think lipid, we add a lot of lipid in the pet food, especially in the conditioner, and 3%, 4%, and even sometimes we are in a meat slurry. In meat slurry also, some meat slurry, they have a lot of oil inside because it depends on the quantity of the slurry. And the oil plays a active role in expansion because it's lubricant. With high oil, that means you can't input mechanical energy, right? With the lower mechanical energy, you can't achieve the high driving force, right? Yeah, but some customers they want to have lipid or oil to be added into the conditioner rather than adding in the poster coating. Because for adding oil, if we add oil in the poster coating just on the surface of the pellets, and easy to get the shelf life will be short, right? Easy to get oxidized, right? And so if added into conditioner, then oil can be combined with the ingredients, with the protein, with the starch combined together, and their shelf life will be longer, right? And also in the recipe, we know that there are some lipids and lipids oxidized in the recipe in the lipid, and easy to get deteriorate of the fat. And generally speaking, if this is the rule of thumb, if the quite high oil added, then you can see the negative effect of on the bulk density with 1%, about 12% addition, then the bulk density will increase 16 grams per liter. I think most this is and also you can see this can be explained perfectly by the nutrition principles. The driving force, we input steam to increase the thermal energy, to increase the driving force. When we do the venting, even sometimes we do the vacuum to suck the steam outside of the extruder chamber to reduce the thermal energy, to control the bulk density. And here, I think for this middle slurry addition, I think we don't have too much time left, right?
还有那个我有是10.1克。
Okay. How much meat slurry? You don't add. Okay. You just produce dry kibbles.
Yes, right.
Just dry kibbles. Okay. Okay. Then there is no need to explain this. Also, this you don't need to. Okay. Then we are going to another topic. here. And what is the feeder you are using for extruder? Losing weight feeder or losing weight feeder? I mean, for losing weight feeder, it is quite interesting because a lot of customer side they have issues on losing weight feeder. First thing that the reason we are using the losing weight feeder because for volumetric we know there are two different types of feeder. One is volumetric feeder. There's no scale, just controlled by the speed of the screw feeder, right? And there will cause the effect that the bulk density is not stable because the bulk density at the bottom of the beam is quite different from the raw material at the top of the beam, right? Because bottom being compressed, bulk density is higher. So your feeding to extruder is not stable. So that's why we choose losing weight feeder. But for losing weight feeder, we need to know that how big the silo here. This is a silo. This is not silo. This is just a beam, right? We need to refill the beam, right? And we need to know how big the beam we need to have. It's not just a beam. It needs to be related to your capacity. And let's say for losing weight feeder, because we know for every refining, when we do the refining to the beam, and it's not the gravimetric, it's not the losing weight feeder anymore. It will automatically turn into volumetric feeder. So I mean, when we do the refining, we have material drop into the beam, and this time it's not the gravimetric feeder anymore. It will be turning into volumetric feeder. So that's why we need to control the refining times. You know what I mean?
So.
Okay. For the losing weight feeder, it's gravimetric feeder, right? But when we add the material, if this beam is empty, or 20 low level indicator is lagging, we need to refill some material inside this beam, right? So in this refining time, it's not the gravimetric dosing anymore.
Wow.
I don't know.
Because
it's not stable. Because when we do the refining, it will have a disturbance on the scale. So it's not the one gravimetric dosing anymore. So that's why we need to control the refining times. To limit the refining times as low as possible, and that's why we say this is not a we say. This is for the professional scale losing weight suppliers. They say we need to have a maximum 30 refining per hour, and for every refining, we need to limit the time, because if the refining time is too long, that means the volumetric dosing will be longer. Gravimetric dosing will be shorter, right? So two points. One is we need to limit the refining times, and for every refining, we need to refining the refining interval, refining, how to say, and we need to, this is why we need to make sure 80 to 85% of the time dosing is in gravimetric model. And the refill should be programmed in between 50 to 80% of the harbor volume, because if the low level indicator is too low, then there are a lot of material to drop to cause material maybe goes through this screw feeder, right? So here, then we can know how big the hopper we need to have, we need to configure. Let's say we have 6 kg per hour, okay? And let's see. Let me think, because a long time I haven't to do this for a long time. This 600 kg need to be completed refining by 30 times, right? Right? So that means every refill 30 times. Every refill 200 kg.
Every period.
Yeah.
2 million and 400 kg.
Yeah, it's 200 kg. And
Every 2 million.
Yeah, okay. Here, we have now capacity 6,000 kg per hour, right? And this 6,000 kg we need to complete in 30 times, right? And every time we need to do 200 kg. And this 200 kg need to be complete in 30 seconds. And then we know the screw feeder capacity. Because 30 seconds, and this is one number, for one number, and we need to multiply 120. And for 1 second, and for 1 time, this is, let's see, this is 30 seconds, we need to have 200 kg. And one number, we have 120 30 seconds. Then we know the screw feeder. So that's why this screw feeder, because there are screw feeder to do the refining for the harbor, right? For the harbor. Then a lot of times the customer side, they have a wrong capacity. The capacity for the screw feeder to do the refining is not enough. If the screw feeder is not big enough, capacity is not big enough, then we can't achieve this target. That means that the gravimetric dosing time can't be ensured, right? And then we can calculate how big the hopper we need to have, because the refill should be programmed in between 50 to 80%. And that means every refining we need to fill up 30%, because 50 to 80%, right? And that means every refining we need to have a 30% volume of refining, right? and this 30% is 200 kg, right? Then we know it's around right. This is the weight the hopper can have, right? Then we know how big the hopper we can have because the bulk density of the material is around 500 gram. No, 500. 0.5 kg per meter, cubic meter, right? Then we know the hopper size. It's um,
1,000.
this is another 0.5千克，是500千克，right?
Yes.
Yeah. Right? So the hopper should be around the 1.2 cubic meter. Otherwise, we can't achieve this target. Then you can't ensure the gravimetric target. So, two points. This is we need to make sure the screw feeder to do the refilling should be with a high capacity more than this, and also for the hopper with the scale, and this hopper volume should be bigger than this. Otherwise, we can't ensure the nosing right function. And also for nosing right feeder, I think that this is a very common issue, and we have encountered this issue in many places. And this one is collections, because we have the soft collections between the screw feeder, right? And if this is too tight, that means your scale can't perform well. And also the filter, because when we do the refilling, it will bring a lot of air into the hopper, and we need to vent the extra air. So we need to make sure this filter bag is not blocked, because most of the customers, they don't clean this filter bag regularly, and if it gets blocked, the actual air can't be exhausted, and then the air inside the hopper is not balanced. Then will play a negative role on the nosing ram feeder. Okay, I think time is over. Do you have any questions?
For me, it's okay. Thank you, sir. So the next time, maybe I will contact you.